Greetings, Dr. Stephen Mujay here, and we are continuing in this class that prepares you for the Network Plus certification. And for this recording, I'm going to be covering Chapter 3. Chapter 3 has a lot of information in it. We might not be able to cover all of it in this recording. If I'm not able to, I'll come back and do a part 2. Okay, so without wasting much time, let me bring in this presentation that I'm going to be going off of. No, slideshow is what I want, and I'll do this from the beginning. So here we go. Again, it's chapter 3, covering addressing on networks. And as I mentioned previously, for this course, this is the book that we are covering right here, Network Plus, Guide to Networks, and that's the 8th edition. So as you follow along, if you don't have it, I would recommend getting it. It will really help you as you plan for this certification right here, the Network Plus. All right, these are the objectives. Find the MAC address on a computer and explain its function in network communications. We'll also talk about configuring TCP/IP settings on a computer, including IP address, subnet mask, default gateway, and DNS servers. We'll also explain the purpose of ports and sockets, and then the domain name and name resolution process, and then using the command line tools to troubleshoot any problems that might occur with network addresses. All right, so there are four types of addressing. If I am sending you a letter, I have to put an address in it, right? So address coming an address to you, and within the address, I'm going to have the name, the street number, the street name, the city, the zip code, the state, and of course, the country. That will ensure that the letter comes to you. When we are doing communications on the network, there is some addressing information that is needed in order for data to travel from one point to another. And that's what we are talking about here. There are 4 main addressing methods, and all these are needed if you are going to have successful communications within the network. So the first address is the data link layer, the MAC address. This is a 48-bit address. I'll talk about that a little bit more. And then we also have the IP address. In terms of the IP address, this could be either a 32-bit IPv4 or the IPv6, which is 128 bits. And in terms of another addressing method, at the transport layer, you have to specify the port number that the communication is going to use. So you select the port numbers, and this happens at layer number 4. And notice that this is layer number 2 in the OSI model. This is layer number 3. This is layer number 4. And then there's the application layer, fully qualified domain names. So you need to have that fully qualified domain name in order for something to get where it needs to get to. And maybe we can put this will fit into layer number 7 of the OSI model. I guess we could put layer number 6 in there as well. All right, so now zooming into the first type of addressing scheme, which is the MAC address. This is traditionally, it has two components. As mentioned before, it's a 48-bit addressing scheme. The 24 bits are known as the organizationally unique identifier, or that or the manufacturer ID. So depending with who manufacture the network interface card, they'll have the 24 bits belonging to them, and different organizations are assigned different organizationally unique identifier. This is a standard that is set out by IEEE. Then the last 24 bits make up the extension identifier or device ID. And as such, those 48 bits are unique. You cannot have any NICs in the whole world sharing the same 24 bits. Right, so we have an example of a network interface card down below here, and there is a MAC. So MAC address, each network interface card, whether it's wired or it's wireless, it's going to have this MAC address, which is made up of these 24 bits. So let's take a look. Right here, I'm going to bring a PC, and I'm going to bring up the command prompt, because this PC has a network interface card. So if I use the command ipconfig, I can just do ipconfig. That's not going to give me the MAC address or the physical address, but what I'm going to do is I'm going to do ipconfig/o, and that's going to include the physical address. So that's the physical address right here. Right, so I'll zoom in right here. This is the physical address, as you can see. Okay, and the naming is slightly different. Typically, you have it separated by colons, but since this is on Cisco devices, they do it in a slightly different way. So I'll jump on this Windows machine that I am and type in ipconfig /o, and there are different NICs, right? So for this Ethernet, you can see this is the physical address right here for the device that I am on. There are some other physical virtual adapters as well. So this would be the NIC. For the virtual Ethernet, that is Hyper-V virtual Ethernet adapter. All right, so I'll jump back right here. Now, moving on to the second addressing, which is IP addresses. A device is going to get its IP in one of two ways. It can be static, meaning that it has been manually configured by the network admin, or you can use DHCP when the device is getting its IP address assigned. There needs to be a DHCP server which will automatically issue it with an IP address. This is what happens when you get to your house and your mobile device connects to the home Wi-Fi. In order for any communication to take place on a network, you need a device needs an IP address. So that IP address can be statically assigned, or it can be dynamically assigned. In the situation of your home, your IP address, or when you go to Starbucks or any of those places and you connect to their wireless Wi-Fi, there's a DHCP server in the background, which is issuing IP addresses. So in large organizations, IP addresses are going to be dynamically allocated because that's the efficient way of doing things. So you can view the settings of the IP address in TCP/IP, and I did show you some of those using the IP config, right? So there are some other numbers that, some other IP addresses that we need to talk about. In order for communication to take place, of course, you do need the MAC address that we started with. You do need the IP address that we're talking about right now. But in addition to a device having its own IP address, it needs other IP addresses so that it can communicate with other devices. And we have a gateway here, and the gateway is going to be the device that nodes or end users use to access the outside world, right? So you may want to go to ESPN.com in order to get there. That's an outside network that you need to access. In order for you to access that network, you contact the gateway. And so there is need to configure the IP address of the gateway on your device, since this would be the device that is going to take you to the outside world. So your computer makes a phone call, as it were, to the gateway, and the gateway will allow you to get to those other websites like ESPN.com. There's also the subnet mask, and basically this indicates how big your network is. The subnet mask stipulates the IP, stipulates the network ID and the host portion. So you take the IP address, you break it into two. The first part is the network ID. The second part is the host ID. And then you also need a DNS server. The DNS server is going to be the device that is going to have a database of names and IP addresses. We use, we're more familiar with names. I mentioned that ESPN website, but that website has an IP address that corresponds to it. So, and the DNS server is going to keep a database such that when you go to ESPN.com, the database will point you to the correct IP, to the corresponding IP address. You may go to Yahoo, CNN.com, FoxNews.com. Those are domain names, but each of those domain names, Facebook, Instagram, they have corresponding IP addresses, right? So since you and I keep track of the names, computers keep track of the IP addresses, and the DNS server is going to keep a database of domain names and IP addresses. So in order for you to be pointed to the right website, like Facebook.com, the DNS is going to make a query. It will keep a database. So that's why you need the DNS address, IP address, so that you can be taken to the right place, right? So what I am going to do is open Network and Sharing Center. Sharing. I'm going to go to, or maybe hold on a second. In order for me to do that, I am going to minimize this, and then I'll open my Network and Sharing Center. I'll move it on this screen. So there is my Network and Sharing Center. And then I can go to this Ethernet adapter. I would go to Properties, and then this is IP version 4. So I'll click Properties for IP version 4. This is the information we are talking about. Notice, hold right? So this right here is the IP address for the device. But for this specific device, it's obtaining it. It's obtaining an IP address automatically. It means it's getting it from the DHCP server. If this option was selected, would come down here and manually assign an IP address. So this would be the static option of assigning an IP address. So this would be the IP address and then the subnet mask. So this is the first option, IP address. The subnet mask is going to be that part that determines the network ID and the host portion. And for as far as this one, this is where you are going to have 255.255.255.0, right? So meaning that you are using the first 24 bits for the network ID and the last 4 bits identify the host. And then there is our default gateway right here. So you enter the IP address for the default gateway, and this is the IP address that you'd need to contact any network outside of your network. I've been giving you the example of Facebook or Instagram. So if you don't know if you want to get to Facebook or Instagram, you don't contact Instagram directly. You go to your default gateway, and your default gateway will take you there. And then down below here, you have a section for the preferred DNS, right? So this is the box where you put in the IP for the preferred DNS server. And remember, the DNS server is going to be the device that has a database of all the IP addresses and corresponding domain names. So this is where you go to configure IP version 4 on a Windows machine. Right, so let me get back here. And then you can use the IP config utility in the command prompt. I think I showed you to find out current TCP IP settings. That's the, this is the command prompt right here. It shows you the current settings of this device that I am on. 2 types of IP addresses, 32-bit, as I mentioned, and then we have the 128-bit IPv4, right? So this is 32-bit is version on binary, and in binary we are operating in base 2, whereas with 128 this is going to be bit base 16, right? So the number is a little bit higher. All right, so let's talk a little bit more about IPv4. This is a 32-bit address, as I mentioned, and it's grouped into 4 groups of 8 bits. You have a set of 8 bits. So let me come over here. So you have 8 bits that could be a set of ones, 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This is another 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. This is another set of bits, right? So now we have 24 bits. And these are ones. Remember, in base 2, it's going to be a 1 or a 0. So I have turned these to ones. And if we were to find a decimal equivalence, this would be 255. This is another 255. and this is another 255. And so that gives us 24 bits. For the other set of bits, I'm going to make them zeros. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put the other 0 up there, right? And the decimal equivalent would be a 0, right? So this gives us our 32 bits, which is why it's referred to as 32 bits. And each of those bits can be either a 1 or a 0. It just so happens that the first 24 bits here are all 1s, and then all the last 8 bits are 0s. So that's how we get to the 32 bits. You may, and in terms of how you write it, so if like the Google DNS server is 8.8.8.8, right? So this is the 32 bits. You write it with dots, right? And then of course there is a binary conversion that you can use in terms of determining how did we get to this 8. You can look up the decimal to binary conversions, but for now I'm simply showing you the 32 bit. It's written in 8 bits, separated by the dots, and each of the 4 octets can be any number from 0 to 255. That's what we saw there. Some IP addresses are reserved. So we have an example of an IPv4 address there, 72.56.105.12. Right, so, and then there's this concept of classful addressing, which determines, which has to do with dividing a line between the network and host portions of the IP addresses, right, by numerical range the IP address falls into. With classful, there are 5 classes: Class A, Class B, Class C, Class D, and Class E. Mostly we use Class A, B, and C, and those are licensed addresses. They're available to use on the internet. So if you need to carry out some communication on the internet, you are going to be using Class A, Class B, or Class C. And then the IEEE, notice IEEE is really staying with us. It recommends the following IP addresses to be used for private networks. And private networks are those networks that are not going to have internet presence. So if all the communications that you're going to take, all the communications you're going to have are going to be within your private network, not going to the internet, you can use any of these IP addresses, 10.0.0.0 through 10.255.255.255. So any IP address that falls into this range can be used on a private IP address. It also means that it cannot be routed on the network. As such, any network falling into the 172.16.0.0 through 172.31.255.255 falls into another private network category, but for Class B. So the first one right here was private range for Class A, and this is for Class B. We also have Class C category for private networks. Any network that falls into the 192.168.0.0 through 192.168.255.255, that's a range for private networks falling into Class C. In terms of those classes, this is a full list of Class A, and this is the range for Class A. It can support approximately 126 networks, but 16 million IP addresses can be issued, meaning 16 million end users can be supported with Class A IP addresses. Class B starts from 126.8.0 to 191.255. And notice something right here that 127 is excluded. We'll talk about that in a little bit. And then Class C is starting from it's starting at 192 and then ending at 223. And notice it can support more networks, but as more networks are supported, it means less IP addresses are going to be available, right? So this increases, maybe I should use the number of appropriate network increases while the number of IP addresses available decreases. Okay, so Class D and E were not available for general use. Class D is used for multi-casting, while Class E is used for research purposes. And then you cannot assign all zeros. You cannot, this is not a usable IP address. It's used for broadcasting. If you want to send a message to all the devices in your network, you can use all 255. And notice the 127 is used for research, or it can indicate your own computer. It's known as the loopback. So if you assign 127.0.0.1, it means you are pointing back to that particular computer. And then we also have the PIPA, automatic private IP addressing. You cannot use this. Typically, when you see an IP address starting with 169, it probably means you have some DHCP issues. This is not an assignable IP address range. All right, then we'll move on to the concept of network address translation. This was, they came up with the goal of conserving IP addresses, because IP version 4 can support, I think, 2 billion IP addresses, but there are way more devices that can get on the internet. So though we cannot have every device getting on the internet with its own IPv4 address. So what happens with network address translation is we can have one public IP address that can be used by several private IP addresses, right? So that's how it works. And then address translation process where a gateway device substitutes the primary IP address with its own public IP address. That's what I was talking about. Port address translation, this assigns TCP port numbers to each outgoing session, between the local host and the internet. So we have a private network, which is on this side. You can see the IP addresses for each device. But when these devices get to the internet, they all use this private IP address. That's how they can browse the internet, because this IP address is not designed to get on the internet. So when they are getting on the internet, they use this IP address, but they use port numbers. So this is pair translation. This is added to the IP address so that as this router sends traffic out there, it will tag it with this so that it knows where to send it when it comes back. Some two variations of NET, static and dynamic. By now, I hope you have gotten an understanding of the difference between static and dynamic. With static, it means that the gateway assigns the same IP address to a host, whereas dynamic, the gateway has a pool of addresses that it is free to assign to a local host. All right, so now time to move on to IP version 6. This is much bigger IP address. It's using 128 bits. Remember, in the in my illustration, I wrote out the 28 bits. So with this, it means I would need enough space to write 128 bits. right? So this is an example of an IP version 6. As you can see, it's pretty long because it's 128 bits, right? So, and this is in base 16. Each block is 16 bits. So this right here is 16 bits. This right here is 16 bits. This right here is 16 bits, right? And these can be referred to as hextets as well. Each block is 16 bits. Leading zeros in a 4-character hex block can be eliminated. So right here, these are all zeros. These are all zeros. You can simply write it as a 0. This can be written as a 0. This can simply be written as D3. That's what they are telling us there. If blocks contain all zeros, they can be written as a double colons, right? So you can see we have 2 sets of zeros right here. You can write them as 2 colons. You have omitted them, but you still need the 8 blocks of 16 to have the 128 bits. So notice we have 1, 2, 3, 4, 5, and 6. The other 2 have been compressed. So it means that they are all zeros. It does not change the value of the IP address when you write your IPs that way. These are some terminologies to keep in mind as you use IP version 6, link, dual stacked. I think as IPv6 was being rolled out, some networks were configured to use both IPv4 and IPv6. So if you are doing that, then that's dual stacked. In IPv4, we had network ID. Notice now we have interface ID. These are the last, the interface ID is the last 64 bits or 4 blocks of an IPv4 address. Neighbors are 2 or more nodes that are on the same link. I skipped the link. This is any local area network bounded by routers. So if we have a router right here with an interface, we consider this a link, right? So the local area network that's coming out of that link is what we are saying a local area network. You have different types of IPv6 addresses, unicast addresses, multicast, anycast, and then these are some examples. We got the global unicast. One thing to keep in mind with the global unicast, this is the IPv6 that can be routed on the internet. Whereas the link local, you can only use it on your link or on your local area network. It cannot be used outside of your link. If we were to make a comparison with the IPv4, this is the equivalence of private IP addresses, and this would be an equivalent of public IP addresses, the global unicast. So if you see anything starting with 2000, that's an example of a global unicast, whereas FE80 is an example of a link local unicast. So when you are using these IP addresses, you are talking with your neighbors. You are not talking with anybody outside of your link or outside of your network. FC00, unique local unicast. We have multicast that can be used. In terms of, you can have auto configuration with IP version 6. The computer can assign itself its own IPv6, and that's done usually with taking the MAC address, because a MAC address is a unique address. You can take that MAC address and create the IPv6 based off of the MAC address. Right here, it lists the steps that a computer takes when a computer is asking the router to provide some configuration information because the computer is going to get, remember those are default gateways, the DNS, it will get some of that information from the router. And of course, there is a process that goes on for a computer to get that information from the router. All right, the next part that I'm going to cover is ports and sockets. All right, so there are port numbers which ensure data is transmitted to the correct process among multiple processes on the computer. This will take us to the third addressing. So the first one was MAC addresses. The second one was IP addresses. Now the third one is ports and sockets. And in this recording, I think I will end with this section. And then in the other one, I'll come and explain the fully qualified domain names. Right. So this represents a process that is taking place on a computer. And this process could be taking place on the web. So we have a port that is associated with that, port number 80, right? So when port number 80 is open, it means that process of accessing the web, a website can go on. And then there is a socket which consists of a host IP addresses. We have identified IP addresses, and then you put that together with the port number. That gives us what is known as a socket. And this is an example of a socket. The first part is an IP address. You combine it with a port number 23, right? So that's an example of a socket. There are port numbers that port numbers are divided into three types. Well-known port numbers, 0 to 1023. Maybe in there you may have 53, 80, as I mentioned, 443. These are some of the popular port numbers. They are used for DNS, HTTP, HTTPS. You have port numbers for DHCP, right? So that's the process that the computer uses when it's carrying that particular task, whether it's asking for an IP address, it's asking for a domain combination of domain name and IP addresses, it's asking for a browser, it uses these different port numbers. Then there are registered ports which fall into the 1024 to the 49,159 range. We have dynamic and private ports. This is the range for the dynamic and private ports, right? So this is a client that is talking with another client, and they are using port 23, which is Telnet. So in order for that communication to take place, for these two to communicate, port 23 has to be open for them to be able to exchange information using the Telnet protocol, using Telnet. And then there are protocols that are not yet covered, that the trivial file transfer protocol, network time protocol, lightweight directory access protocol, server message block, different types of protocols that are going to have different port numbers that they use, right? So there are much more that we haven't covered, right? But that exist out there. I'll give you some assignment to look up these protocols and see the port numbers that are traditionally assigned with these protocols. Just like I mentioned, the HTTP, its corresponding port number is 80. So I'll give you the homework to see what are the port numbers that are used by these protocols that are listed on the screen. that would be all for this recording. In the next one, I'll cover domain name systems as well as the troubleshooting process. Thank you for watching. Have a good one.